Alright, this is section 1.2, which is dealing with the concept of limits. So what I have here is the definition of limits, which, as with lots of things, as you read the definition, sometimes it's still kind of hard to understand exactly what it's explaining, but I'll talk you through the parts here. Alright, so it says if f of x becomes close to a single number L. Okay, so first of all, f of x is your function. So you have some function that's going to get close to some number. We're looking at a particular number here that they're calling L. And this is going to be as your x value approaches C from either side. So they're using the capital L and the lowercase c there just to represent numbers. Okay, so your function is approaching a number L as x approaches a number from either side. Then the limit of the function, remember f of x is your function, so the limit of the function as x approaches C is L. Okay, now what this means is, of course, it refers to the fact that as x approaches C. So this C is referring to an x value. Okay, and we're going to look at these graphically as we go through. So C, the lowercase c, is going to represent an x value. The capital L is actually representing a y value. So you can see here where I've come back in parentheses and written that L is a y value. Now, the notation that you're going to be seeing used with limits. So if you're talking about a function or finding the limit of a function, of course LIM is just your abbreviation for limit. So your limit as x approaches C of your function. So like if you're writing this on lined notebook paper, like this is all written in one line, so you kind of write it, kind of small, and then you write your function beside it, and then you tell what the limit is. Now remember, your limit, your L, is always going to be a y value. So when you're calculating this, remember, it's always equal to a y value. They're just using the uppercase L to represent this y value. So again, this is what I have down here. Is just how you would read it. The limit of the function, the limit of f of x as x approaches C is L. So that's just kind of dealing with your notation there. Now there are different ways that you can determine limits. And this isn't anything that you have to have in your notes. If you don't want to write this down, that's fine. But ways that you can determine your limits, you can do it numerically, which is what we're going to look at first of all, using a table of values. We're also going to look at it in a minute graphically. So you're looking at your graph. How do you figure out your limit? And analytically means you figure it out by hand, okay? And you use some algebra skills, of course some calculus skills as well. We won't get into the analytical part of it in this section. This section will just introduce you to the numerical and the graphical. Alright, so the first one we're going to look at here. Of course, I've already got some of this filled in for you, but then I'm going to show you how to fill it in as well. Alright, so our function is, of course, x cubed minus 1 divided by x minus 1. This is just saying x can't be 1 because you'd have 0 on the bottom. So that's just kind of a technicality there. So this is our function. So you're asked to find the limit as x approaches 1 of this function. So they just wrote f of x here instead of writing this. So sometimes you'll see the actual function written here, and sometimes they'll just put the notation f of x. But they're telling you that the limit as x approaches 1 of this function is going to be equal to 3. And this table is going to prove to you that it is equal to 3. Now if you think back to the definition that they gave you for limit, they said, they referred to it, as your function gets close to a particular value. So this means as you get closer and closer to 1, what is your y value doing? Remember, this represents your y value. So in creating a table, in the middle of my table here, of course, this top row is going to be my x values. Here in the middle, I put 1 because that's my x value that I'm approaching, okay? F of x, of course, f of x, remember, is the same thing as y. Okay, so these are y values, these are x values, okay? So if you're talking about getting close to 1 from both sides, from either side of the function, like, you've got to use small numbers, okay? So like, if you look at the numbers coming in on this side, you've got 1.2, 1.1, 1.01, 1.001. So these numbers are still very small numbers, or very close, I guess I should say, to 1. And the same thing coming in from this side, 0.8, 0.9, 0.99, 0.999. These numbers, as you come from this side, are getting closer and closer to 1. These numbers are decreasing, but of course they're having to decrease in order to get closer and closer to 1. Now I'm going to show you how to do this on your calculator actually with the next problem. Here I'm just wanting you to see the numbers and you know what it is that you're looking for. But like if you were to take 1.2 and you were to plug it into this function, so you'd have 1.2 to the third power minus 1 divided by 1.2 minus 1, and you put that in your calculator, this would be your decimal approximation. Okay, so just like you've done many times, you can take an x value, plug it into a function, and get a y value. So that's all that's been done here, is the numbers in that top row have been plugged into that function in order to get those in that bottom row, which are your y values. Now, what happens if you directly plug in 1 though? Remember here it said x can't be 1. If you directly plug in 1, you get 1 on the bottom, which is undefined. And I've got a statement about this in just a minute, but sometimes the value that you're going to be given here actually is going to make this undefined when you plug it in, but you're still going to have a limit. Okay? So, as your x's are getting closer and closer to 1, what you're supposed to be asking yourself then is, what are my y values doing at the same time? So if you start comparing your y values, 3.6, 3.3, 3.030, 3.001, these numbers are gradually getting smaller and smaller and smaller and getting closer to actually just a 3. And the same thing's happening here. These numbers are actually getting larger, but as you go from one number to the next, those are gradually getting closer and closer to the value of 3. So actually what you would have here in this table is a 3. So that goes back to here where I said this is actually going to be your answer. But when you look at your numbers in your table, both sets of numbers on both sides are closing in on the number 3. Remember, these are your y values. Your limit is always equal to a y. Now, if you look at this graphically, this is actually the graph of this function that we've been looking at. So it's the shape of a parabola, but you have a hole right here. Okay. Now, if you notice this hole, of course, this little part right here is just an enlarged section of this right here. But right here where this hole is, you'll notice your x value is 1 and your y value is 3. Okay? So, as x approaches 1, remember I said your answer is always a y value, so as you approach 1 from both sides, what y value is it that you're closing in on? So like if I look at it from, let me get a different color here. If I look at this from the right hand side, like right here is x equal 1. Okay, so if I follow, of course this graph here goes up, forever. So if I look at this graph coming in from the right side, it's closing in on this circle right here. Okay, then if I look at it from this side, from the left side, it's also closing in on that circle right there. And that circle has a y value of 3. So as x approaches 1, it is approaching a y value of 3 at the same time. So your graph approaches x equal 1 and y equal 3 at the same time. Now that point's not actually on that graph because it's an open circle, but like I said, and you'll see more of what I'm talking about in a little bit with some other examples, you don't have to be able to take this x value and plug it into that function and it actually work. Okay? The function doesn't have to be defined because you're just wanting to know what is it getting close to.